section 11.1 has to do with areas of a parallelogram. Remember, a parallelogram, opposite sides are parallel. It might be in the form of a square or a rectangle or just a straight parallelogram. But the area is always the area formula is always the same. It's the base times the height. Now the height is going to be the vertical line that's perpendicular to the other side. Now obviously if you had a rectangle, then this would be your base and this would be your height because it joins at a 90-degree angle. Parallelogram, it's going to take a little bit more work to get that height. So here's an example. Find the area of this parallelogram. Okay, so this little 60-degree right here is going to make a big difference because that's going to tell you how to get the height here. So the area is going to be the base times the height. Well, if that's 18, this is also 18. So I have that much. It's 18 inches. Now, to get the height, I'm going to have to use a little trig. So if I'm standing right here, I need to know opposite, and I have hypotenuse, which is the sine. So the sine of 60 degrees is equal to opposite, which in this case is the height, over the hypotenuse, which is 12. So the height is going to be what you're going to get when you multiply the 12 times the sine of 60. So 12 times the sine of 60 is going to give me a 10.4. So that's what you're going to use up here for the height, 10.4. So that times 18 is going to give me an area of 187.1. This is in units of inches, so it's inches squared because that's inch times inch, or inches squared. Here's another example. This time I have a 30-degree angle up here, so I'm just going to say that I'm going to stand right here. Okay, I have got this side, which means I have the hypotenuse in this little triangle right here. So if you pull that triangle out, I've got a 30-degree right here, I've got a 24 right here, and I need to know the height. So I've got base, which is 32, times I got to figure out the height. So if I'm standing here, I know adjacent, and I want to know adjacent, and I have hypotenuse. So that's the cosine. So the cosine of 30 degrees is equal to the adjacent, which is the height, over the hypotenuse, which is the 24. So the height is going to equal 24 times the cosine of 30. Now you could have just, you know that this is 60, so if you wanted to use sine, you could have come down here and stood and used the sine of 60 is equal to h over 24. So you could have used either on this. So 24 times the cosine of 30 is going to give me 20.8. So the height is going to equal 20.8 that I'm going to multiply by my 32, which is going to give me an area of 665.6. This is inches again, so it's inches squared. Real world problems concerning this. The Canes are planning to sod some of their yards, so I want to find out the square yards of grass needed. Now, obviously I don't want to put grass in the garden, I don't want to put it in the garage, and I don't want to put it in the house or the walkways. So what I'm going to do is I'm going to find my total area, which would be 200 times 150, and I'll subtract out these individual parts. So total area is 200 times 150, which is base times height, and that's going to give me 30,000. And I'm going to subtract out the garden, okay? So the garden is going to be 50 times 40, which is 200. And the garage is would be 60 times 50, which is, oh, actually it's 2,000 and 3,000. Okay. And then the house and walkway is going to be 100 times 60, so it's going to be 6,000. Okay, so I'm going to subtract all those out. So I have 30,000 minus 2,000 minus 3,000 minus 6,000. And I'm going to get 19,000, but understand this is feet squared. Now that's significant because this asks for square yards. So I'm going to have to do dimensional analysis to get rid of my feet squared and get yards squared. So I need to find the correlation between those. So the easiest way that I can tell you to do that is if you think about a yard. Okay, a yard squared, I have 3 feet wide and 3 feet long. So this would be 1 yard squared, which would be 3 feet times 3 feet. So you know that 1 yard squared is equal to 9 feet squared. Okay? So then I go 9 feet squared equals 1 yard squared. So I'm going to take the 19,000, I'm going to divide it by 9, and I'm going to get an answer of 2,111 yards squared. Now that's rounded off. You're also going to put these on a coordinate plane. So here is this quadrilateral on the coordinate plane. The very first question is it a square, is it a rectangle, or is it a parallelogram? Well, you can check. It's not, based on what I drew, unless I drew it really wrong, it's not going to be a square or a rectangle. So I want to check to make sure it's a parallelogram, which means the opposite sides would have to have the same slope, would be parallel. So I want to use my calculator formula to check the slope. So slope of AB, if I put those in, see, I'm going to go to my formula. Okay, go to program, go to slope, and A is going to be -4, -3. B is going to be 2, -3. And I'm going to have a slope of 0, which should make sense because it's a horizontal line. If you did D and C, you should also get a slope of 0 because it's a horizontal line. So far so good. Now I want the slope of AD and BC. So AD, I'm going to use -4, -3, and -2, -6, and I'm going to get a slope of -3/2. So let's see on BC if I get the same. So B is 2 and -3, and C is 4 and -6, and again I'm going to get -3/2. So I know that this is a parallelogram. So it tells me to find the area. Now remember, the area is equal to base times height. Now this one's easy. If it was crooked, I'd have to use the distance formula. But because this is completely horizontal, this is from -2 to +4. So my base is 6, -2 to +4. If I check my height, I'm going to go up, if you will. That's going to be my height because it's perpendicular to it. I'm going to go up 1, 2, 3. So I have 18, and I don't know the particular unit, so we'll just call it units squared. All right, here's another one. This one, again, asks, is it a square, rectangle, or just a parallelogram? Well, you can tell that it's not a square, okay? So I'm going to check to make sure it's a rectangle, which means this corner has to be, they have to form a 90-degree angle. So again, I'm going to be doing like all the sides, so I have the slopes of all the sides, because 90-degree angles have opposite reciprocal slopes. Okay, so there's all the sides. I'm again going to use the slope formula on my calculator. So using AB, -2, 3, and 4, 1 gives me a slope of -1/3. BC is going to give me a slope of 3. So far so good. I know that that right there is a 90-degree angle. Okay, CD is going to give me -1/3. So I know that is a 90-degree angle. Okay, DA, -3, 0, and -2, 3 is going to give me a slope of 3. So I know that, and then I could compare those two, and I know that all 4 of those are 90-degree angles. So I know that's a rectangle. To find the area of this rectangle, I'm going to have to use the distance formula and the distance formula. So area, if you will, is the base times the height. The base is going to be the distance from D to C. So I'm going to go to Programs, I'm going to go to Distance, and I'm going to put in D, -3, 0, and I'm going to put in C, which is 3, -2, and I find that the base is approximately 3.2. And now I'm going to do the same thing with one of the two sides, either AD or BC. And so -3, 0, I'm doing AD, and -2, 3. That's going to give me 3.2. So I'm going to multiply this together times 6.3, and that's going to give me approximately 19.9 units squared. Okay, so you're using your slope formula here, and you're using your distance formula here. All right, your homework on this is page 598 through 599, 9 through 28 all.